calm lake sits under the dark sky. No lava, no ash, no warning siren, just water, hills, and sleeping villages in northwest Cameroon. If you were standing there on the night of the 21st of August 1986, you might have seen nothing unusual. A crater lake can look peaceful from the surface. That is what made this one dangerous. Because beneath Lake Nyos, something had been collecting quietly. Not monsters, not magic, gas, carbon dioxide. The same gas you breathe out every few seconds. The same gas that gives soda its fizz. Ordinary, invisible, and usually harmless in the open air. But inside this lake, it had become a hidden reservoir. And before the night was over, about 1,746 people and thousands of animals would be dead. The strange question is not simply, how can a lake explode? The better question is darker. How can something look completely still while it is already becoming a disaster? Lake Nyos sits in a volcanic region. That does not mean a volcano had to erupt with fire and rock that night. The famous version often gets this wrong. It says the lake exploded, and the mind immediately imagines flames, thunder, smoke, and people running from a mountain. But the real story is quieter. Carbon dioxide from deep volcanic sources seeped upward over time. It dissolved into the deep water of the lake. And because Lake Nyos was deep, pressure helped keep that gas trapped below. Think of a soda bottle before you open it. It looks calm. But inside, pressure is holding gas inside the liquid. Now imagine the bottle is a lake, and imagine people live in valleys below it. That is the uncomfortable shape of this story. For a long time, the lower layers of Lake Nyos stayed separate from the upper layers. The lake was stratified, which simply means its water did not mix from top to bottom like a shallow pond might. The deep water sat under pressure. The gas remained dissolved, the surface stayed calm. Nothing about that surface told the truth. This is where the story bends. 2 years earlier, another lake in Cameroon had already given a warning. Lake Nyos released carbon dioxide in 1984 and killed 37 people. It was smaller than what would happen at Nyos, but it mattered. It was the system speaking once before, shouting. The problem was that the meaning was still not clear enough. Scientists did not yet fully understand this kind of disaster as a practical, urgent hazard. Villagers near Lake Nyos had no reason to treat a quiet lake as something that could suffocate them in their sleep. There was no simple household warning for invisible carbon dioxide, no smell you could trust, no color in the air, no fire on the horizon. The warning existed. The world had not yet learned how to read it. By the 21st of August 1986, Lake Nyos had been storing carbon dioxide for years. Deep below the surface, water held more and more gas. At some point that night, something changed. The exact trigger is still uncertain. Maybe a landslide disturbed the water. Maybe heavy rain or wind played a role. Maybe the deep layer had become unstable enough that only a small push was needed. The important point is not that one proven object caused everything. The evidence is less certain there. What is clear is the chain. Gas-rich water began to rise. As it rose, pressure dropped. As pressure dropped, carbon dioxide came out of the water as bubbles. Those bubbles made the rising water lighter, so it rose faster. That pulled more deep water upward. That released more bubbles. And the circle began feeding itself. A feedback loop is a circle where the result comes back and makes the next result stronger. Here, the rising water released gas, and the gas made more water rise. The lake had found its own trigger. Then, the stored danger escaped. Carbon dioxide burst out of the water in a huge release. Some accounts describe a violent disturbance at the lake, but this was not a normal volcanic eruption with lava and ash. The killer was not fire. It was air that could no longer be breathed. Carbon dioxide is heavier than normal air, so instead of rising like smoke and disappearing into the sky, it stayed low. It flowed downhill. It moved through valleys the way water might move, filling the lowest places first. That detail matters. A gas cloud in open space may spread and thin. A dense gas cloud in a valley can become a trap. Around Lake Nyos, the valleys led toward villages. Nyos, Cha, Cam, Subum. People were asleep. Animals were tied or resting. Houses were still standing. There was no battlefield, no broken city, no burning forest. And that is part of what made the aftermath so confusing. When breathable air is displaced, the body does not get what it needs. People can lose consciousness quickly. Many victims likely never understood what was happening. They were not choosing to ignore an obvious danger. The danger was invisible and already around them. This is the cruel simplicity of carbon dioxide. It does not need to stab, burn, or explode in the way we expect. It can kill by replacing the air. By morning, the disaster looked almost impossible. Villages were silent. People and animals were dead. Buildings remained. The lake was still there. To anyone arriving afterward, it must have seemed like a disaster with the usual evidence removed. No obvious fire, no obvious weapon, no obvious storm, just absence. Investigators had to work backward from bodies, survivor accounts, lake chemistry, and the shape of the land. Early confusion was understandable. Some survivors reported strange smells, and people feared poison, gas, or volcanic activity. But the strongest explanation became carbon dioxide released from the lake. The famous phrase, "exploding lake," survived because it is easy to remember. But it hides the more important truth. Lake Nyos did not kill because it was mysterious. It killed because it was physical. Volcanic gas entered water. Deep pressure stored it. Stable layers trapped it. A sudden release turned dissolved gas into a cloud. Valleys guided the cloud. Sleeping villages had no warning. This was not one moment. It was a system. And systems often fail before anyone knows what to call the failure. That is why Lake Nyos became a scientific turning point. Along with Lake Manoan, it helped make limnic eruptions a recognized natural hazard. A limnic eruption is a sudden release of dissolved gas from deep lake water. It sounds rare because it is rare, but rare does not mean imaginary. After Nyos, the question changed. It was no longer, what strange thing happened? It became, how do you stop a lake from doing this again? The answer was surprisingly plain. A pipe. Not a wall. Not a bomb. Not a machine from science fiction. A pipe placed into the deep water could bring gas-rich water upward in a controlled way. Once started, the rising water releases carbon dioxide gradually, like opening a soda bottle slowly instead of shaking it and ripping off the cap. Scientists and engineers tested degassing systems. Lake Nyos eventually received a permanent pipe in 2001, with more pipes added later. Lake Manoan also received degassing work. The idea was simple in human language. Do not let the lake store danger until it chooses the timing. Let it breathe under control. That does not make the lake safe forever in some magical way. Volcanic lakes still require monitoring, maintenance, and public risk communication. But it turned a hidden natural hazard into an engineering problem that people could manage. That is a remarkable reversal. The same lake that once seemed like an impossible killer became something measurable. Gas levels could be studied. Water layers could be checked. Pipes could reduce pressure. The invisible became visible to science. But the cost of learning was enormous. Today, you live around invisible safety systems all the time. Gas detectors, weather alerts, building codes, evacuation plans, food inspections, engine sensors, warning labels. Most of them are boring when they work. That is their purpose. A good safety system does not feel dramatic. It feels like nothing happened. Lake Nyos is a reminder of the gap between a real hazard and a recognized hazard. Something can be scientifically real before society has a name for it, a warning system for it, or a habit of respecting it. The lake did not become dangerous on one night only. The danger had been gathering below the surface. The disaster happened when that hidden storage finally connected with geography, sleep, poverty, limited information, and human settlement. A calm surface met a deep system, and the system moved downhill. That is the part the famous version leaves out. The lake did not explode like a bomb. It released what it had been quietly holding. And sometimes, the most dangerous thing in a landscape is not the thing that looks violent. It is the thing that looks still.